Hi everyone, let's take a look at some rational expressions and go over the step-by-step process to simplifying them. So in this example, we have expressions with a binomial denominator. So we're going to get started with reading the question. We have a monomial here and a binomial here. So we're going to start off with step number 1, which is factor everything. Since we have only one term in the numerator, so we're going to just write that one term. It's the only factor in the meantime. And in the denominator, for 6 and 4, we have a common factor of 2. And for x squared and x, the greatest common is x to the power of 1. And from 6x squared, we are left with 3x. And from 4x, we are left with simply 2, negative 2. Now, this is completely factors, so let's take a look at the factors we have. So we have x in the numerator, denominator we have numbers 2, we have x, and then we have 3x minus 2. Now, before we start simplifying, we want to state the restrictions. Remember that the restrictions are that the denominator cannot equal 0. So denominator is made of a factor of 2. Now, it makes no sense to say 2 different than 0 because 2 is different than 0, so forget about this. We have x. X cannot equal 0. And what happens if x becomes 0 is 2 times 0 times anything. Well, it's going to be times negative 2. That will make the whole thing 0. And also, 3x minus 2 shouldn't equal 0. Now, when we state the restrictions, we state them on the variable, not on the expression, which means that we need to isolate x. So this will turn to 3x different than 2. So just solve it like a regular equation, even though you don't have an equal sign. And divide by 3 both sides to get x isolated, so x different than 2 over 3. And once you have taken care of restrictions, you can start off simplifying. So x will divide x in here. They're both factors, right? Into 1, x divided by x equals 1. So in the numerator, then you're going to have the number 1. In the denominator, you'll have 2 and then 3x minus 2. And on the side, we're going to add the restrictions that x has to be different than 0 and different than 2 over 3. And we're done. Moving on to the next example, I encourage you to try this on your own. And I'm going to do this a little bit faster because we are aware of the process here. So everything here is together in one term, so every part of the term is a factor. So we'll write it the way it is. Denominator. For 6 and 12, we have 6 common. For x squared and x to the power 1, we have x to the power of 1 common. For y and y squared, y power 1 and y squared, we have y power 1 common. So then we'll have just x left from the first term, right? See, when you multiply back, you get the same thing. And here we have 2. We have x and y common, so y is going to be left inside. And now it's time for us to state the restrictions. So we're going to say that the restrictions are x cannot equal 0, y cannot equal 0, and x minus 2y shouldn't be 0, which means x is different than 2y. So that's one way of stating this particular restriction, x different than 2y. We can also say y different than x over 2. It's equally true, right? So it doesn't really matter how, but we would like to state the restrictions on x. That is more common. Now, as you can see, we have 1, 2, and then 3 restrictions here. So once you state your restrictions, you're free to start simplifying. So numbers 3 and 6 will simplify to 1 over 2. So x in the numerator and x in the denominator will simplify to 1 over 1. You don't have to write this. I'm just trying to explain it for now. And lastly, we have y and y simplify to 1 over 1. And in the denominator, we have x minus 2y. Simplified form in this case will be 1 over 2 x minus 2y. And obviously, you can go from this step all the way down here. And that's the way it should be. And we're going to add the restrictions different than 0, y different than 0, and x different than 2y. And that would be the final answer. Now, in the next question, we have some examples where we have to remove a factor of -1. So what does that mean? And we went over this in class as well. But the idea is that when we have two opposite numbers, such as 3 and -3, when we divide them, they will divide to -1. If you have two opposite terms, let's say x squared y and negative x squared y, then the ratio will be -1. So opposite numbers, opposite terms will divide to -1. That would simplify, and the answer will be -1. Now, in a similar way, often we encounter opposite binomials. Opposite binomials will also divide to -1. So I'm going to try to squeeze in a few more examples here. Now, if you have, let's say, a binomial of the form x minus y, the opposite will be -x and then minus y. So sometimes the way this looks in expressions is -x plus y, or even better, x minus y over y minus x, okay? So I'm just, rearranging the terms. So when you see that the terms are opposite in the binomial, respectively opposite, then we're going to say that the division will give a -1. So why do we need to do this? It makes the simplification process a lot easier. So let's take a look at an example. So what you see in here is 3 minus 2x over 4x minus 6. And what I see that is not really very common here is that the terms in the numerator are arranged from constant and then to higher degree. So I would rearrange the terms from highest to lowest degree, which means the x term will be first, and then we have plus 3, and then in the denominator we have 4x minus 6. So whenever an expression starts with a negative leading coefficient, that's the leading coefficient because it's the term of the highest degree, the leading term, and this is the coefficient of it, then we want to take the -1 out. And if you take the negative out, then you get negative 2x minus 3, denominator 2 times 2x minus 3. So as you can see now, you see they're exactly the same thing, right? And what we're going to do is before we start simplifying, we'll state the restriction. We're going to say 2x minus 3 cannot equal 0, 2x different than 3, x different than 3 over 2. This will be the restriction, and it is perfectly fine if you just write this as a restriction without all these steps. Now, we're going to simplify our chop here, and you see that we end up with -1 over 2, and the restriction will be x different than 3 over 2. And that's how it gets done. Now, we're going to take a look at the next example. We have y squared minus x squared over x plus y squared. So you probably recognize in here the difference of squares, which I am going to write as in factored form as y minus x and then y plus x. In the denominator, we have x plus y squared. I'm going to rewrite this as x plus y and then x plus y. Now that I factor it completely, so I'll state the restriction. So we have x plus y repeating twice. So I only have to show the restrictions once, obviously. So I'll say x has to be different than -y. And what you see in here is y plus x and x plus y. They are basically the same thing. So these two will simplify, and we are left with y minus x over x plus y. And to make this look a little bit better, we're going to rewrite this in proper format so the terms are in the exact same order. And we'll have -1 x minus y over x plus y, or even better, negative x minus y over x plus y, where x has to be different than -y. Now, In the next examples, we're going to look at trinomial numerators and denominators. So here we go. We're going to start off with factoring. So factor the numerator. So two numbers that multiply to negative 10 and add to 3. That has to be plus 5 and minus 2. And two numbers that multiply to positive 15 but add to 8 would be plus 5 and plus 3. So before we simplify, we want to state the restrictions. Remember that we have two factors in the denominator. They both have the potential of becoming 0 for a specific value of x. So we're going to say that neither one of them can be 0. So we're going to say x has to be different than negative 5 and different than negative 3. And now we are allowed to simplify here. And the final answer would be x minus 2 over x plus 3. And I have to change the color here. All right, so x minus 2 over x plus 3 with a condition that x cannot equal negative 5 or negative 3. And that's the end of it. Now, you can do this as well. You can try this on your own. I think I've missed something in here, so a sign. And we are going to work on it together. So what you see here is a trinomial in the numerator. So 2y and y. So we need the product to be negative 15, but we need the sum to be negative 1 in here. So 15 is 3 and 5. So I'm going to try the 3 in here and the 5 in here. That should work out nicely. 6 minus 5. It looks like the middle term is negative. So negative 6y, positive 5y is a negative y. You can break down the middle term. Again, in simplifying rational expressions, you don't have to show the step-by-step process of how you factor. Now, in the denominator, we have the 4y. I'm going to add this. I hope it's an addition. And we have 4y squared plus 13y plus 3. So let's see how this is going to turn out to be 4y squared and 13. So that's going to be a 12th. Okay, good. So we're going to break down number 3 into 1 and 3 here. And for 2y, I'm going to try in here the 4y and a y, and that is because we have a 13 in here. And 4y and y is going to be 4y squared, and it's going to work out. I think that I needed a negative in here, so we're going to need a negative. And I am going to say that the two signs here are negative to make this negative sign. And it's time for restrictions. So we're going to say 4y minus 1 different than 0, so y different than 1/4. And y minus 3 different than 0, so y different than 3. So once you've stated your restrictions, you're free to simplify and to state the final answer. And that would be 2y plus 5 over 4y minus 1, where y isn't allowed to be either 1/4 or 3, and that's the final answer. Thank you for learning with me. Please remember to practice and follow the homework outline to select the questions from the attached practice. Bye for now.